Okay, let's dive right into this explainer. If you follow global resources at all, you know the game of finding materials is changing fast. But right now, in Pakistan, there is this massive disconnect between the incredible wealth hidden underground and the actual tools being used to find it. Today, we're unpacking exactly how modernizing minerals exploration, using elevation data, remote sensing, GIS, and AI, is going to completely revolutionize the extraction of both metallic and non-metallic minerals in Pakistan. We're talking about building a future of mining with modern tools that deliver high profit with a super low investment cost.
$6 trillion. Let that number just sink in for a second. That is Pakistan's estimated untapped mineral wealth. We're talking about everything from highly valuable metallic minerals like copper and gold to absolutely critical non-metallic minerals. And yet, despite sitting on one of the most lucrative geological gold mines on Earth, the local industry is still, well, kind of stuck in the past, using completely outdated tools and missing out on some massive economic betterment.
I have to share this incredible story from Sufyan, a mine owner in Gilgit-Baltistan and the founder of GeoMine AI, because it just hits the nail on the head. He was sitting with a veteran mine owner in Chilas who was hunting for $1 billion payload using decades-old guesswork, literally pulling out a fading paper map from 1978 to decide where to dig. It's a story playing out all over the country, relying on gut instinct and word of mouth to map out a trillion-dollar industry.
So let's get right into Section 1. The $6 trillion problem.
Picture this for a second. Traditionally, a geologist literally has to walk the rugged mountain terrain, collect physical samples, and write up a report. It takes months, it costs millions of rupees, and it only covers a tiny fraction of the area. It's wildly expensive. Modern tech completely flips this script. By using satellites and AI, we can scan hundreds of square kilometers in just days. It drastically lowers the investment cost while massively increasing how accurate our targets are.
Moving on to Section 2, Eyes in the Sky.
Modern exploration relies on three primary tools, and they're basically superhuman eyes. We've got optical, thermal, and radar sensors that capture data way beyond what human vision can process. Satellites aren't just up there taking pretty pictures, you know. They are gathering multi-dimensional data. Radar sensors, for instance, can literally see right through thick cloud cover to map the structural geology, while thermal sensors map heat emissivity to tell different rock types apart. But here is the absolute game changer: hyperspectral imaging. Because everything on Earth absorbs and reflects light differently, these hyperspectral sensors capture hundreds of narrow spectral bands to reveal hidden indicators that your eyes just cannot see. We're talking about invisible features that point straight to iron oxide alteration zones, specific clay minerals, or even stressed vegetation caused by metal-rich soils hidden underneath. It is fascinating stuff.
And what exactly are these sensors hunting for? A massive array of both metallic and non-metallic minerals scattered across Pakistan's incredibly diverse regions. You've got highly lucrative metallic minerals like copper in Balochistan and gold in Gilgit-Baltistan. But you also have vital non-metallic industrial minerals like barite and manganese down in the Uthal and Bela areas. The sheer geological diversity is staggering, and remote sensing can map the whole shebang.
Which brings us to Section 3, the ultimate digital blueprint.
Think of Geographic Information Systems, or GIS, as the brain of this entire operation. It layers all these distinct data points into one cohesive digital canvas. You can't just look at a single satellite image and know where to dig, right? You have to build a blueprint. First, you pull in multispectral imagery to spot mineral alterations. Then, you layer in the elevation and topography data. Finally, you overlay the radar data to see the underlying structural faults. By harmonizing data from these specific satellites, explorers create a rock-solid geological framework, even in the most inaccessible mountain ranges. Notice how each satellite has its own specific job. Sentinel-2 handles the alteration zones. Aster gives us the lithological map. SAR handles the structural faults, which are essentially the underground cracks where mineral-rich fluids travel. And SRTM-DEM maps the physical elevation. When you stack these together in GIS, the invisible suddenly becomes visible.
Now, let's check out Section 4, AI, the Modern Prospector.
Okay, before AI, geoscientists had to manually interpret complex structural maps. They were painstakingly tracing this intricate web of red lineaments just to find fractures across different rock types. Actually, scratch that. It wasn't just painstaking, it was incredibly tedious and left a massive window open for human error, especially when trying to cross-reference it with spectral and elevation data across thousands of square kilometers.
But then, you feed that raw structural data and satellite imagery into machine learning algorithms, and boom, they generate these probabilistic target maps. It completely takes the guesswork out of the equation. The AI learns the exact signatures of known mineral deposits, scans the whole digital blueprint, and outputs a clear map. Red for high probability, yellow for moderate, green for low. You instantly know where your highest chances of success are. No more blind digging.
Let's look at a real-world example in Balochistan to prove this isn't just theory. A mining company had a massive exploration license but absolutely no idea where to start. A traditional ground survey? That would have taken them over 6 months and tens of millions of rupees just for Phase 1. But by applying AI and satellite intelligence, they got a targeted report in exactly 2 weeks. 2 weeks! The AI pinpointed 3 high-priority zones based on spectral, structural, and topographic data. That is an unbelievable saving of both time and capital.
Finally, let's wrap this up in Section 5. High profit, low cost. This quote right here is the ultimate takeaway. Technology doesn't replace human geologists. It just ensures their incredibly expensive fieldwork is aimed at the absolute highest potential targets. You still need human experts to drill, to verify, and to actually build the mines. But instead of sending them out to wander the mountains blindly, you are dropping them exactly on the X that marks the spot.
So what is the actual return on investment here? By integrating remote sensing, GIS, and AI, Pakistan can totally shift to a low-investment, high-profit mining model. Whether we're looking for metallic ores or non-metallic industrial minerals, this workflow eliminates the financial risk of drilling dry holes, it protects the environment because we only disturb the earth where we know the resources are, and crucially, when global investors look at Pakistan, they don't want to see a paper map from 1978. They want data-driven, AI-backed intelligence.
The satellites are already up there. The AI models are trained. The technology is here, it is proven, and it guarantees high profit, low-cost extraction for the betterment of the industry's future. So the only question left is, will Pakistan embrace these modern tools to finally unearth its $6 trillion future? Or will it be left in the dust trying to navigate the 21st century with a fading paper map?